Hello, my name is Colleen D'Alessandro, and I am the FAA New England Regional Administrator. I'm very pleased to be with you today to talk about the aircraft operations and airspace over Boston and surrounding communities, including Boston Logan International Airport, Hanscom Field and Bedford, Beverly, Lawrence, and Norwood airports. The FAA, along with the Massachusetts Port Authority and representatives from the airline industry, want to take this opportunity to give you an overview of aircraft operations and airspace over the greater Boston region, including airport development and the roles that each of us play. While some of you are very familiar with the airspace above the Boston region and operations at Boston Logan, we understand that this topic may be unfamiliar to others. So today, we hope to bring you all up to speed on how and why aircraft operate as they do in the greater Boston region. We'll walk through a plain language breakdown of how we operate the airspace above you. We'll explain key arrival and departure operational flows at Boston and operations by smaller propeller-driven aircraft at a few of the surrounding general aviation airports. But first, a little history. Boston Logan turns 100 years old in 2023. I would like to take this time to highlight some of the key milestones in that history. The airport started operations in September 1923, and at that time it was mainly used by the Massachusetts Air National Guard and the United States Army Air Corps. During this time, it was known as Jeffrey Field. Colonial Air Transport, the airport's first commercial airline, initiated service in 1927 between Boston and New York. The airport continued to grow, and by 1949, the Boutwell Terminal, which now houses terminals B, C, and D, was built. In 1955, the airport's first air traffic control tower was built. Boston continued to grow with 4 runways and numerous connecting taxiways and terminal buildings. In order to support the growing airport, a new 22-story air traffic control tower was opened in 1973. As Boston Logan grew, residents around the airport became concerned about the impact of the airport on their communities. In 1985, the airport, continuing to acknowledge community concerns, developed a voluntary sound insulation program where approximately 418 structures, including schools and homes in East Boston, were sound attenuated. To date, a total of over 5,400 homes and 36 schools have been sound attenuated, with approximately $170 million in investments from FAA and Massport. In 1995, Massport established the Logan Airside Improvements Planning Project to evaluate earlier FAA airport capacity studies in order to support certain recommendations of the studies. At the time, Boston Logan Airport was consistently ranked as one of America's most delayed airports. In response to the FAA's record of decision on the Logan Airside Improvements Planning Project Environmental Impact Statement in 2002, the Boston Logan Airport Noise Study, which is better known as BLANS, was conducted to identify and implement measures to reduce noise impacts to communities surrounding the airport. The measure committed the FAA to work jointly with Massport and the Logan Airport Community Advisory Committee to develop the scope of a noise study that would include enhancing existing or developing new noise abatement measures. The study was conducted in 3 phases. Phase 1, during which the study was referred to as the Boston Overflight Noise Study, or simply BONS, began in 2003 and culminated in October 2007. Phase 2 began in early 2007 and was completed in December 2012. And Phase 3 began in July 2013 and was concluded in December 2016. During these phases, various noise abatement measures and procedures were recommended and evaluated to include the implementation of performance-based navigation, or simply PBN, arrivals, departures, and approaches, and runway use measures were also considered. The implementation of new technology PBN procedures, including RNAV, was part of a nationwide FAA initiative to increase the safety, efficiency, and resiliency in the nation's air traffic system, and offered new possibilities for noise abatement. Continuing our strong partnership, in 2016, the FAA and Massport signed a memorandum of understanding that established a framework for cooperation in exploring, evaluating, and advancing changes to procedures to reduce impacts from overflight noise, while at the same time maintaining the safety and efficiency benefits of PBN procedures at Boston. This MOU resulted in a partnership between FAA, Massport, the Massachusetts Institute of Technology, and the Massport Community Advisory Committee. And in 2017, an initial set of recommendations were proposed. These are known as Block 1. When the procedures were first presented to the FAA, some did not meet safety criteria. So the FAA, working within the MOU framework, made changes, but maintained the path over the bay away from homes while maintaining compliance with design and safety criteria. The first change moved aircraft departing on runway 15 right further north away from the densely populated areas near the town of Hull. The second change moved aircraft on approach to runway 33 left out over the water, similarly away from densely populated areas near Hull. Pilots can use both procedures 7 days a week during both day and night hours. And these two community-requested procedures were published in December 2021 and are now in use. More recently, in early 2022, a second set of recommendations called Block 2 were proposed. These include modification to runway 22 left RNAV, standard instrument departure, with a speed restriction to enable an earlier turn to the east, which shifts aircraft tracks further north away from the town of Hull. The second recommendation was to implement a new overwater RNAV approach for runway 22 left that crosses the Nahant Causeway from the east to join a 4-mile final approach. Arrival flight paths from the south and east are moved over water instead of overflying populated areas north and northeast of the airport. These community-requested procedures are currently in the FAA design process, and we hope to publish them later this year. While a lot has changed since the airport first served commercial passengers in 1927, the FAA continues to work in partnership with Massport, the airlines, and the surrounding communities on reducing the negative impacts of aviation. I hope this overview provides a better understanding of the history of Boston Logan and our commitment to continually engaging in meaningful dialogue with communities.
Hello, my name is Lisa Whelan, and I'm the CEO of the Massachusetts Port Authority. Welcome to the FAA's Boston Area Communities Public Information Workshop. I want to thank the FAA for coordinating this forum for community leaders and for residents. We fully support community engagement events like this and believe they provide an important opportunity to inform others of our decision-making processes and provide us with a chance to respond to questions and hear comments from neighboring residents like you. The Massachusetts Port Authority, or Massport, is an independent public authority. Massport owns and operates 3 airports: Boston Logan International Airport, Worcester Regional Airport, and Hanscom Field. We also own and operate public facilities in the Port of Boston, including Conley Container Terminal and Flynn Cruiseport Boston. And we are the landlord for maritime and commercial real estate tenants. At Massport, our mission is to be a world-class organization of people, moving people and goods, connecting Massachusetts and New England to the world, safely, securely, and efficiently, with a commitment to sustainability, our neighboring communities, and diversity, equity, and inclusion. Massport's facilities are essential for a range of economic activities, including trade, commerce, tourism, and economic growth in the city of Boston, the Commonwealth of Massachusetts, and the entire New England region. Our facilities generate more than $22 billion in annual economic impact and support over 100,000 direct jobs. Boston Logan International Airport is one of the state's most critical transportation assets. In fact, this year, Logan turns 100. Logan has a comprehensive network of nonstop service to major domestic and international destinations and is served by a diverse array of airlines. This diversity of airlines provides a competitive and comprehensive route network for the traveling public and for air cargo. In 2019, pre-pandemic, Logan accommodated 42.5 million passengers. However, Logan activity declined by 98% at the height of the pandemic. Although we have recovered substantially, overall volumes in 2022 were down by about 15% relative to those pre-pandemic levels. As Logan recovers, we continue to watch key developments that may impact our recovery. Both Worcester Regional Airport and Hanscom Field offer more choices for the region's business and leisure travelers. Worcester Regional Airport serves the central Massachusetts region, offering commercial airline and general aviation services. Delta, JetBlue, and American provide easy access to Florida and New York. Massport and the FAA have invested over $150 million in the airport, including the Cat 3 instrument landing system, which is state-of-the-art equipment for low-visibility operations. Hanscom Field is the region's busiest full-service general aviation airport and serves a vital role as a general aviation reliever for Boston Logan. Hanscom Field provides easy access to the greater Boston area and its suburbs, and has 3 first-class fixed-base operators, also known as FBOs, that provide flight support services, including aircraft refueling, maintenance, repair, and storage, along with passenger service. Although the pandemic required Massport to cut some of our planned investments, we continue to modernize key aspects of our infrastructure. Our projects include adding gates and modern space to Terminal E, connecting Terminals B and C, and replacing antiquated roadways. We recently hosted President Joe Biden as we celebrated a grant from the FAA, which is funded by the Bipartisan Infrastructure Law. That grant will be used to help pay for improvements to Terminal E and terminal area roadways. Recognizing that Massport's facilities, and particularly Boston Logan, are situated in an urban setting with community neighbors, Massport works hard through our comprehensive community engagement program to reduce impacts from our operational activity, pursue environmental actions to benefit our surrounding communities, and ensure economic benefits of our facilities reach our closest neighbors. Massport's park and open spaces in East Boston and South Boston provide the community with a space to gather and to enjoy. Later this year, we will be opening Pierce Park 2, creating an additional 4.5 acres of green space along the East Boston waterfront. We are making targeted community investments, such as a residential sound insulation program, in collaboration with our FAA partners. Massport also has an active charitable contributions program, awarding grants monthly to local organizations. We support civic and social service agencies through our Community Summer Jobs program, and award scholarships to high school students yearly through our STEM and Memorial Scholarships program. Finally, Massport employees participate in a number of volunteer and donation efforts that benefit our neighboring communities, including the Backpack Project for Children, a Thanksgiving food drive, and our Children's Winter Coat Drive. An important and highly successful strategy to reduce congestion and emissions while providing important customer service options is Massport's HOV initiative. Expanded HOV options include 5 Logan Express sites, like the Back Bay service, a Silver Line connection to South Station, on-airport free shuttle buses to the Blue Line, and water ferry docks. A year ago, Massport set an ambitious goal to become net zero by 2031. This goal applies to Massport-controlled emissions, identified as Scope 1 and Scope 2, and in parallel, we are continuing to work with our customers, partners, and tenants to reduce their emissions, known as Scope 3. Our net zero plan places Massport at the forefront of leaders in the Commonwealth with a commitment to action by 2031, contributing to the Commonwealth's goal of reducing its emissions by 75% in 2040 and becoming a net zero state in 2050. 1 year into our net zero journey, we advanced multiple initiatives, including seeking LEED Gold certification for Terminal E's modernization, generating 75% more energy than planned from our Terminal C solar array, submitting potential maritime and aviation projects to the Department of Energy's Regional Clean Hydrogen Hub, and installing EV charging stations at Worcester Airport. Massport will also encourage and support emission reductions by our business partners, encouraging HOV and EV usage to and from Logan Airport, supporting tenant fleet management conversion to electric ground service equipment, facilitating sustainable aviation fuel, also called SAF, and SAF's development and use here, and supporting energy efficiency and promoting waste reduction. In closing, thank you for this opportunity to inform you about what we do every day at Massport and to share with you our efforts to reduce our environmental footprint.
This video provides an overview of aircraft operations and the airspace in the greater Boston area. We'll talk about how air traffic operates, the complexities of Boston's airspace, and the procedures air traffic controllers use to keep airplanes safely separated. Boston Logan Airport and the nearby general aviation airports combined are a complex airspace that operates over a population of more than 4 million people. The region is served by numerous airports with commercial flights and smaller general aviation propeller aircraft, business jets, and military flights. Each airport, regardless of its size or the type of aircraft that operate there, has its own airspace with dedicated arrival and departure routes that guide aircraft in and out of the Boston area, connecting to the larger National Airspace System, or NAS. These airports serve a wide range of aircraft of different sizes with varying performance capabilities. It is critical to keep different types of aircraft and the numerous traffic flows separated from each other. The primary responsibility of the FAA's air traffic control system is to provide the safe, orderly, and expeditious flow of air traffic. This is done by teams of FAA air traffic controllers that ensure airplanes are safely separated while maintaining the most efficient flow of air traffic. Air traffic control requires great precision and is highly complex. When an airport is constructed, the runways are built to align with the most common wind directions in the area. This is because aircraft take off and land into the wind to maximize performance and safety. In the Boston area, winds are variable and come from all directions, and most airports in the region have at least 2 runways to accommodate aircraft operations and varying wind conditions. As shown in this animation, Boston Logan has 6 runways. Since each runway end is treated as a separate surface, there are actually 12 runways. Runway identification is based on the magnetic compass heading the aircraft is facing as it lands or takes off. For example, runway 422 is oriented with a magnetic compass heading of approximately 40 degrees in one direction and 220 degrees in the opposite direction. If you drop the 0 at the end of the compass heading, you will get 4 and 22. Parallel runways are further designated with L for left or R for right as you approach or depart the runway. At Boston Logan, aircraft will land and take off typically in one of 3 operational flows, identified by the direction aircraft are landing and departing, depending on the winds. This example shows aircraft in northeast flow, landing and departing on runway 4 left and 4 right, and departing on runway 9. The other primary operational flows include southwest and northwest. In the busy Boston region, airports may seem far apart. The distance between airports is the same on the ground as it is in the sky. However, aircraft travel at a great rate of speed, greatly reducing the duration time between airports when compared to travel by car. This is another reason why air traffic controllers work to ensure aircraft are properly separated from each other. Aircraft operate using both instruments and visual references. These 2 types of flying are called Instrument Flight Rules, IFR, and Visual Flight Rules, VFR. These types of flying require different levels of air traffic guidance. However, all aircraft must maintain safe separation from each other and terrain. Air traffic controllers help manage and separate all types of aircraft, from the largest commercial jet to the smallest propeller aircraft within the designated airspace. For example, when Boston is in northwest flow, aircraft landing on runway 32 fly over aircraft landing on runway 27. These aircraft are given altitude and compass headings to follow to maintain required separation. Not only are there operations from multiple airports in the region, there are also helicopter and seaplane operations which each have their own unique routes. Helicopters have 7 primary routes within the Boston area, used by the military, news agencies, law enforcement, emergency medical services, and sightseeing operations. Helicopter routes were designed to be over major transportation corridors. Helicopters may stray from these routes for operational needs, such as during news events or when providing emergency services. Seaplanes generally operate in the Channel and along the Charles River using visual references to fly. When a seaplane lands, arriving aircraft at Boston Logan must be sequenced to make room for the seaplane. Finally, there are numerous general aviation airports in the greater Boston area, which predominantly serve propeller and business jet aircraft with limited commercial service. Many of these general aviation operations are small propeller training aircraft that fly a pattern around an airport to land and take off. In order to reduce impacts on neighboring communities, voluntary noise abatement routes have been implemented, such as the pattern at Norwood Airport to reduce operations over the town by aircraft turning to 230 degrees at the runway end, then turning on course after reaching 1,000 feet mean sea level. As you can see, there are many layers to managing airspace, including high traffic volume, proximity of surrounding airports, helicopter and seaplane routes, and weather. All of this is accomplished every day by a team of highly trained air traffic controllers.
Hello, my name is Barrett Brown, and I'm an operations manager at Boston Tracon. I've been actively involved in air traffic within the Boston area for the last 17 years. This presentation will walk you through the flight procedure poster boards for the arrival and departure procedures in the Boston region. Each of the following boards shows a sampling of approach and departure procedures with current day flight tracks color-coded in blue. These flight tracks represent a random sample from summer 2022, unless otherwise noted. The flight tracks and procedures are all overlaid on a map for the surrounding area. Each flight procedure board is oriented with north facing up. The name of each flight procedure is shown by an arrow on the map containing a 5-letter name. Arrows for arrival procedures point toward the airport, while arrows for departure procedures point away from the airport. For example, this board shows 4 departures: the Highland, Pats, Celtic, and Bruin. These are called SIDs, or Standard Instrument Departures. A few acronyms are used by air traffic controllers explaining the boards and in the text. The spelling of each departure and arrival procedure is limited to 5 letters. For example, the spelling of HYLND, departure, is pronounced Highland. The stars on the board are locations of waypoints, which are fixed navigational points in space that the aircraft fly to. Just as with the spelling of procedures, waypoints are spelled with 5 letters. For example, the COLYN waypoint would be pronounced calling. The flight procedures are colored purple for departures and orange for arrivals. These colored paths show the existing published flight paths. Surrounding the paths are dispersed path areas in either pink for departures or yellow for arrivals. These areas show the typical locations where aircraft fly and account for the different routing to avoid hazardous weather, for operational need, or for safety. When aircraft fly in these areas, it is typically due to a pilot receiving a compass heading from air traffic control. A vector is a magnetic compass heading assigned to an aircraft in a radar environment by an air traffic controller at the Boston Consolidated Tracon or the airport tower. The procedures will use satellite and GPS for guidance, as well as ground-based navigational aids. For arriving aircraft, once on the Standard Terminal Arrival Route, or STAR, controllers may either give the pilot a vector to the final approach, fly the entire procedure and would be issued the RNAV approach, or use traditional ground-based navigation called an ILS. RNAV is an acronym for Area Navigation that allows properly equipped aircraft to fly precise routes all the way to the runway, and ILS stands for Instrument Landing System. Aircraft arriving or departing may be vectored off their procedure for operational need, safety, or for hazardous weather. Aircraft that are vectored are given a different heading to fly than the published procedure. The bullet points on the right side provide additional details about the procedures. This board shows an overview of existing arrival and departure procedures in Southwest flow at 5 busy airports in the greater Boston area. There are 67 airports within Boston Consolidated Tracon's airspace boundary. As this board shows, the airspace in the greater Boston area is busy and complex, with aircraft arriving and departing at numerous airports simultaneously. Air traffic controllers manage over 2,000 flights per day within this airspace that is part of the overall national airspace system, ensuring the safety of those in the air and on the ground. This board shows the same flight tracks as the previous board, but these arrival and departure radar flight tracks are color-coded by altitude. These flight tracks are a random sample from summer 2022 and represent a typical day when the operational flow at Boston Logan is in the southwest flow. As you can see, aircraft departing Logan fly over the bay, and those that turn to the north or east cross the shoreline at or above 10,000 feet, shown by the flight tracks color-coded in green as they cross back over the shoreline. While aircraft typically cross the shoreline around 10,000 feet on these published procedures, aircraft are required to be at least 6,000 feet. Airports that have predominantly propeller aircraft operations, such as Norwood and Beverly, have numerous aircraft operations at lower altitudes, including training aircraft that stay near the airport and fly a takeoff and landing pattern.
Hello, my name is Scott Coleman, and I'm a staff support specialist at the Boston Air Traffic Control Tower. I've been actively involved in aviation and air traffic for more than 42 years, with the last 30 of those years being at both the Consolidated Tracon and the Air Traffic Control Tower. This animation shows the runways used when Logan is operating in the northwest flow. When winds come from the northwest, we use runways 27, 33 left, 33 right, and 32. Aircraft may land on runway 27 and 32 and depart on runway 33 left. The primary runways in this configuration are runway 27 and runway 33 left. Runway 32 is only available for landing aircraft. It is not used for departures in any operational configuration. This board shows the published standard terminal arrival routes or STARS when operating in a northwest flow. Aircraft may land using one of the 3 arrival procedures or may be given a vector by air traffic control. During busy times, aircraft may need to be vectored to be properly sequenced to land, ensuring aircraft are properly separated. Aircraft arriving on runway 27 from the west, east, and south fly on published STARS to line up for the final approach. Aircraft from the south on Roebuck will cross the shoreline at or above 8,000 feet mean sea level. Aircraft are then sequenced to line up on the final approach. They must remain 3 miles apart laterally, or what we call miles in trail, to maintain safe separation. Aircraft that land on runway 32 are given a vector heading by air traffic control. This board shows one of the departure operational flows when the winds are from the northwest. In this configuration, runway 33 left and runway 27 are used for departures. Aircraft departing runway 33 left fly to the tech waypoint, then turn to the north, west, or south to continue on the published procedure. Air traffic control sequences departures based on aircraft speed, destination, safety, and operational need. A slower aircraft may be turned immediately after flying over the tech waypoint if a faster aircraft departs after it. This allows for proper spacing to be maintained between the aircraft. As aircraft transition out of the local Boston airspace, separation between aircraft increases from 3 nautical miles to 5 nautical miles. Additionally, aircraft flying the same route from satellite airports need to be put in sequence with Logan traffic. This board also shows one of the departure operational flows when the winds are from the northwest. In this configuration, just runway 33 left is used for departures. Similar to the board we just looked at, aircraft departing runway 33 left fly to the tech waypoint, then turn to the north, west, or south to continue on the published procedure. Air traffic control sequences departures based on aircraft speed, destination safety, and operational need. As aircraft transition out of the local Boston airspace, separation between the aircraft increases from 3 nautical miles to 5 nautical miles. As you can see on the graphic, aircraft flying to the west may fly on one of 4 initial routes out of the Boston area.
This animation shows the runways used when Logan is operating the southwest flow. When winds come from the southwest, we use runways 22 left, 22 right, runway 27, and runway 15 right. Aircraft may land on runway 27 and depart on runway 22 left, while departing on runway 22 right and 22 left, and occasionally runway 15 right. The primary arrival runways in this configuration are runway 27 and runway 22 left. This board shows the published standard terminal arrival routes, or STARS, used when operating in a southwest flow on runway 27 and runway 22 left. Aircraft may land using one of the published arrival procedures or may be given a compass heading by air traffic control. During busy times, aircraft may need to be vectored to be properly sequenced to land, ensuring aircraft are properly separated. In this configuration, the primary arrival runway is runway 27, and the secondary arrival runway is runway 22 left. This is due to many factors, including the runway length and landing characteristics of aircraft. When aircraft land on runway 22 left, they may be involved in land and hold short operations, called lasso. This means an aircraft will land, then stop prior to an intersecting runway that another aircraft is landing on at the same time. Not all aircraft are capable of lasso, therefore runway 27 is the primary runway. Aircraft that land on runway 27 are not required to land and hold short. This board shows the published standard terminal arrival routes, or STARS, used when operating in a southwest flow on runways 22 left and 22 right. As this graphic shows, aircraft flight tracks that are within the yellow area on the map were given a compass heading by air traffic control to be vectored for landing. The main reason for vectors in this operational configuration is due to the difference in aircraft speeds on final approach, and ensuring proper separation exists between the multiple aircraft coming from different directions en route to the final approach course for landing. This board shows one of the departure operational flows when the winds are from the southwest. In this configuration, runway 22 right and runway 22 left are used for departures, and occasionally runway 15 right. Aircraft departing runway 22 right fly to the TJ waypoint, then turn to the north or south to continue on a published procedure. Just like the other operational flows, air traffic control sequences departures based on aircraft speed, destination, safety, and operational need. The pink area on the map shows where aircraft typically fly in a southwest flow. Aircraft may turn after reaching tasket to maintain proper spacing between departing aircraft. The majority of aircraft on the westbound SIDS fly to the HUMO waypoint and then fly direct to the next waypoint on the route. When aircraft are landing on runway 27, aircraft that depart runway 15 right first fly runway heading, which is 150 or 150 degrees, then fly into tasket and onto their destination. This animation shows the runways used when Logan is operating in a northeast flow. When winds come from the northeast, we use runways 4 right, 4 left, and runway 9. The primary runway in this configuration is runway 4 right. This board shows the published standard terminal arrival routes, or STARS, used when operating in a northeast flow on runways 4 right and 4 left. As this graphic shows, aircraft flight tracks that are within the yellow area on the map were given a compass heading by air traffic control to be vectored for landing. These aircraft are sequenced to land with aircraft coming from the east and south. This board shows one of the departure operational flows when the winds are from the northeast. In this configuration, runways 4 left, 4 right, and runway 9 are used for departures. Aircraft departing runway 4 right fly to the Nahant waypoint, then turn to the north or south to continue on a published procedure. Just like the other operational flows, air traffic control sequences departures based on aircraft speed, destination, safety, and operational need. Aircraft that are turned once reaching the end of runway 9 are typically propeller aircraft, which are assigned vectors to keep them separated from the flow of jet traffic.
This board shows the visual helicopter routes in purple. Helicopters operate in the Boston area using both visual and instrument flight rules and include training, emergency services, medical transport, news, sightseeing, and law enforcement. Helicopter operations that most operate using instrument flight rules are medical transports going to and from the numerous hospitals in the Boston area. Oftentimes, helicopters fly at altitudes lower than propeller aircraft for the purposes of their mission, but must always remain clear of aircraft operating at Logan. For example, when aircraft arrive on runway 4 left or right, helicopters may fly at 400 feet mean sea level on portions of the bay or quarry routes. Also, helicopters may fly in other areas as they transition to and from the purple helicopter routes. In addition to the runways at Boston Logan, there is also a seaplane base in the harbor. There are several seaplane operational flows that allow for simultaneous seaplane operations with the regular Logan air traffic. We will look at the innermost portions of the seaplane arrival and departure paths. As the seaplanes near the water landing area, they arrive either from the southeast and depart to the northwest, or they arrive from the northwest and depart to the southeast. Under ideal wind conditions, we can have them arrive from the northwest and then depart to the northwest. The seaplane operations that occur at Boston are conducted by a commercial operator and must follow the same rigorous standards set by the FAA for all commercial air carriers, including having 2 pilots, specific aircraft maintenance requirements, and required periodic checks of the pilots by FAA flight standards personnel. These operations are conducted with Cessna Grand Caravan EX aircraft, which are multi-million-dollar sophisticated aircraft. The Cessna Caravan has operated all over the globe for decades. When equipped with amphibious floats, which add almost $1 million to the cost of the aircraft, they can land on water with the wheels up and on hard runway surfaces with the wheels down. The ability to land on water or land gives the operator flexibility for safety, weather, or other operational considerations. For example, on any given day, if the weather is not conducive to water operations, the seaplanes can simply land and depart at Logan Airport.
Hello again. I'm Colleen D'Alessandro, the Regional Administrator for the FAA's New England region. Thank you for participating in our virtual public workshop. I will be the moderator for this discussion. I'd like to cover 3 procedural items before we start the Q&A. First, if you're having technical issues connecting to the workshop, you can text our tech support number anytime during the workshop. That number is 949-478-0253. Second, this workshop will last for 2 hours. We have 2 workshops scheduled, so you can also attend our next workshop on Thursday evening. Third, we're also live streaming on the FAA's Facebook feed and the FAA's YouTube channel. A recording of this workshop will be available on those channels. Because addressing community concerns about aviation is a joint responsibility that we share with the aviation industry and airports across the country, we're pleased to have our airport partners from Massport joining us today. In addition, we have representatives from JetBlue, Cape Air, the Airline Pilots Association, and the National Business Aviation Association. They'll answer your questions about their operations and offer their perspectives. So let's get to it. Let me introduce you to our panelists. We'll start with the FAA team. Richard Doucette. Richard is an FAA Environmental Protection Specialist. Next, we have Veranda Johnson. Veranda is our FAA Environmental Protection Specialist. Next, we have Barrett Brown. Barrett is an Operations Manager at Boston Consolidated Terminal Radar Approach Control, or better known as our TRACON. We have Flavio Leo. Flavio is the Director of Aviation Planning and Strategy at Massport. And also from Massport, we have Steve Sulprizio, the Manager of the Noise Abatement Program. Next, we have Heidi Williams. Heidi is the National Representative for the National Business Aviation Association, or NBAA. We have Lee Brown. Lee is the Manager of Strategic Airspace Programs at JetBlue. And we have Steve Phillips, Director of Operations at Cape Air. And then lastly, we have Captain Ryan Call, representing the Airline Pilots Association, or ALPA. We sincerely appreciate the participation of our panelists. The challenges around aviation and noise are complex and must be addressed by the entire aviation community. I hope that the information provided in the live Q&A provide value. For your participation in the meeting, if you registered on the Zoom platform, please submit your questions on the Q&A tab. If you're watching on Facebook or YouTube, please submit your questions in the platform's chat area. Before we start the question and answer portion of the meeting, I wanted to ask our panelists a couple of questions about how the airport, airspace, and aircraft all operate in this space. Okay, so this question, I'm going to open this up to a number of our panel members, NBAA, ALPA, and the airlines. As we saw in the opening video, Boston area is incredibly complex for many reasons. We have variable weather, numerous airports, complex airport layouts, and all different kinds of airplanes operating in the complex airspace. For our panelists, how is Boston unique for your operations? And I'll start with Heidi from NBAA.
Well, good afternoon, Colleen, and glad to be participating with the group. You know, for the business aviation operator, Boston is unique. I mean, certainly being surrounded by water is something we don't have everywhere, but the complexity of operations with the mix of general aviation airports in the area, including seaplane operations and airline operations altogether, it makes for an interesting dynamic, right? And then you couple it with the New England weather. That's certainly another complexity. When you throw that all together, it makes it just kind of a unique place.
Thanks, Heidi. Ryan, what's your perspective from ALPA?
Well, thanks for having me today. I've got about 20 years experience of flying in the Northeast, from smaller piston engine airplanes to larger jets. To start off on a broader spectrum, you know, tied into the Northeast and the New York area, it kind of makes Boston kind of fall into that category as well. Geographically, we're close to large buildings in downtown, lots of water, weather, and we have a mix of operators like we just discussed in our video with seaplane operators, helicopters, and larger satellite airports around. Definitely a very busy environment compared to most of the other airports that I operate in.
Thanks, Ryan. And I'm going to ask Steve to chime in also from Cape Air.
Hi, thanks for the opportunity to participate today. Yes, with Cape Air, we fly relatively smaller aircraft, usually 9 passengers. And it's a very dynamic environment, especially around the Boston area. We integrate with air traffic control. It requires a lot of standard procedures that pilots have to be aware of. And to operate safely, we do a lot of coordination with air traffic control and the other airlines to follow these standard procedures and comply with all the many regulations that are required to operate safely. But it's a privilege to work with these professionals.
Thanks, everyone. And one thing that I didn't hear mentioned was while Boston has a significant kind of waterfront around it, that brings with it ships. And while we don't think of ships very often when we're worrying about airspace, I've been up in the air traffic control tower when traffic has had to been stopped due to ships passing through the channel. So that's another complexity we have in Boston. I'm going to move on to the next question, and I'm going to ask Lee Brown and then Heidi to answer this one for us. The second question is about how aircraft decide where to operate. We're seeing commercial air traffic across the country at levels higher than those before COVID, and general aviation activity has also remained steady. I'd like to first ask Lee with JetBlue and then Heidi with NBAA, what key factors do operators use to decide flight schedules and what airports to serve?
So for JetBlue, I mean, we are a friends and family airline. We work really hard to build routes and networks that support where our customers want to fly. And that is, often determined by market preferences and what we hear from customers in terms of the destinations and the frequency of flights that they want to have. That is something that is determined by the operators and the airlines. The FAA does not determine the frequency of flight, although as we heard in the earlier presentations, we are certainly subject to the routes and procedures that are part of the airspace definition.
So, Colleen, I'll just add, from the business aviation or general aviation perspective, we don't necessarily have specific markets or schedules, rather. Like an airline operator, we're a little more dynamic and probably flexible in determining where exactly our destinations are. But, number of different factors will play into that, whether that be weather or determining where your ultimate destination is and what the closest airport may be. We also would factor in, traffic management initiatives of the day, or if there are constraints in the system. We do have the flexibility to sometimes use the general aviation relievers around Boston if Boston is congested or there's a weather constraint. But one other factor for the general aviation public is, sometimes your flying is dependent upon where services are available. And so if you're, for instance, doing training, you're going to go to an airport where the flight training is available.
Thanks, Heidi. And you mentioned the general aviation reliever airports. So an example of that in the Boston area would be what?
Be Hanscom.
Thanks. Next question is, I'm going to start with Barrett from our TRACON. And this question is, we received a lot of questions and comments about this one. How is the FAA designing and managing performance-based navigation, or better known as PBN, including PBN procedures, including RNAV, which is an acronym for area navigation? Barrett, why don't you kick us off on that one?
Well, thank you, Colleen. First of all, the FAA is continuously modernizing the national airspace system. It's what we have to do to make things work as we move forward in the future. We are committed to moving from our land-based navigational aids, ILS systems, into more of a satellite-based navigation system, which by definition is known as our performance-based navigation, or PBN. It's consistent both with congressional direction, and it's needed because of the amount of growth we have in the system on a regular basis. PBN is really important for air traffic. It makes our flight paths more efficient. It remedies airspace congestion, and it simplifies air traffic control, which inherently increases safety in our operations. Predictability is the key to success when it comes to air traffic. Knowing where planes are going to be on a regular basis, where in there, and then to have them be where you expect them to be, is a huge part of PBN, and makes our jobs much easier to do.
Thanks, Barrett. Steve, from Cape Air, what's PBN mean to you?
Yeah, the use of the RNAV or area navigation approaches is mostly the biggest benefit for planes like we fly at Cape Air, specifically because we can do straight-in approaches to many of the other airports surrounding the Boston area and the Cape and Islands and up in the New England area, as opposed to having to do circling maneuvers and doing visual approaches only. This allows straight-in instrument approach procedures in much lower weather conditions. And so the reliability goes up with the use of area navigation as well.
When you say reliability, I'm thinking the reliability of getting the plane on the ground, but we're always going to get the plane on the ground. So what do you mean by when you say reliability?
It provides us to operate with lower weather conditions than would be the case if we didn't have the straight-in approach procedures. So we're able to operate in more reliable conditions with lower weather, so that we can go more often and have better reliability in that sense.
Mm-hmm. Okay, thanks. So what about from an air carrier perspective? Maybe Ryan, you could touch on that.
Yeah, the PBM usually starts for us when we're, in our en route or cruise portion of our flight, and basically allows us to descend from a cruise altitude all the way down to the terminal area where we would be talking to the controller at a constant rate descent at idle. So not only does it put us over certain fixes at altitudes and speeds to help out air traffic control, but it also allows us to descend efficiently on a constant path, kind of at an idle power setting. So it makes it quieter and it makes it more fuel efficient until we get down to lower altitudes and come into land. So it's basically one of the big benefits of a star or standard terminal area arrival. And then GPS approaches and RNAV allow us to use similar approaches if ground-based operations navigation's not working, and also gives us different weather minimum criteria to fly to a lower altitude in order to see the runway and in order to land.
Thanks. And I guess I don't want to simplify it too much, but I'm not a pilot. And so when I think of GPS approach or departure procedures, I think of my car, and I have my nav system up on the screen as opposed to the paper map on my lap.
Exactly. It allows us to plan ahead too. We know where we're going to be the next fix and there on out, and how we're going to exit the airspace. So it allows us to plan more and anticipate where we're going to be and be ahead of the aircraft as opposed to being behind it, so to speak.
Great. Thanks, everyone. Okay, next question. I'm going to ask Steve Salprizio from Massport to first answer this one for us. How is the air quality monitored in communities under the flight path?
Colleen, I'll take that one. This is Flavio.
Okay, thanks, Flavio.
Thanks for the question and welcome everybody. I can answer the question in three parts. Part number one is we do an annual modeling of our emissions using the FAA approved AADT model, both on noise and air quality, and we report that out annually in environmental data reports, and it looks at all the major emissions factors from VOCs to NOx, CO and others. We do that on an annual basis. We also work very closely with the FAA's SCENT program, which is a lot of the research is being done by the FAA on noise and emissions. And we actually are supporting monitoring being done by BU and Tufts around the airport. We've also supported Olin College on their emissions monitoring. All this monitoring helps to support the science and all the work going on at the national level. And finally, it also informs a lot of our actions that we do locally. For example, on that Zero program that's underway that Lisa mentioned in her video regarding getting Massport and Logan airport, and in particular towards a net zero world. So I think we're addressing the air quality issue in those three ways.
Thanks, Flavio. So Richard, from a FAA perspective, anything you want to add to that? Maybe I could ask you to just, Flavio mentioned AEDT, and you could start off by telling us what that stands for.
Sure, that's the Aviation Environmental Design Tool. It's a computer model that the FAA owns. It's used around the country and around the world to calculate both emissions from aircraft and the noise generated by aircraft. So it's the same inputs into the model, and you can get either the air quality information or the noise information. The only other thing I would add to what Flavio mentioned is the EPA has, through which they've delegated to the states through the Clean Air Act, a nationwide network of air quality monitors. They're not specifically located at airports, but they are located across the country. And for a number of airport projects, we can use the data from that to determine the trends in air quality over time, and then we can calculate how those might be impacted by airport projects.
Okay, thanks. Next question. I'll kick us off and then turn it over to Barrett. Why can't there be more dispersion when aircraft depart on runway 33 left? There are too many runway 33 left departures, and why can't they be spread out? One of the biggest challenges with dispersing noise is getting communities to agree on how to share the noise. Dispersion doesn't reduce the total amount of noise. Instead, it simply distributes it amongst more people. So for everyone who gets less noise, there are others in neighboring communities who will be getting more noise. And that's a challenging conversation to have with communities or between communities. We've been working with Massport on an RNAV study launched in 2016. And that effort has engaged MIT through their research efforts to understand how we can use supplemental metrics to help facilitate discussions that might be needed with communities to determine how to share the noise from aircraft operations. MIT did make a recommendation that would have provided greater dispersion from the runway 33 left departures, but at this time, it was rejected by the communities. So, that procedure was an alternative to the existing procedure, but it brought forward with it some, as I said earlier, challenging conversations between communities, because as you saw from the boards that were presented earlier in this workshop, runway 33 left departures go over communities as opposed to having options such as some of the other runways have and the other flows to be able to divert those aircraft operations initially over water. So Barrett can probably speak to that part better than I can, so I'll turn it over to him.
Yeah, thanks, Colleen. I'll just touch on a few things with runway use in general. The runway use at Boston and any airport in particular is based on a multitude of issues, whether it be wind, weather around the airport, construction on the airport, aircraft capacity by the amount of arrivals or demands that are the arrivals or departures that are coming in and going at any time at the airport, buildings and structures around the airport itself that impact the climb out procedures for different airlines. There's just a lot of things that go into it. So we actively, from air traffic control's perspective, do try to spread out the use of runways as much as we can. But when it comes to the airlines and the type of aircraft they use and how long they're flying, if they're going to the West Coast, they're full of fuel, they're real heavy, they need a longer runway. 33 left is our longer departure runway for that situation. So we've seen a large increase, I think, of coast to coast domestic flights in and out of the Boston area. So we're seeing, I think, some more regular use of runway 33 left at this point. It is also based on the time of year. The wind direction in this part of the country does change dramatically based on the season we're in. So you'll see we'll transition from a 4-9 type operation to a Northwest 2733 left configuration. So it does spread out throughout the year. I think people just tend to see it more during one particular season, and I think that it's just happening on a regular basis. As far as dispersing departures evenly or or I guess not evenly, but dispersing them across the board when they come off the end of the runway, that creates a challenge as well. We operate in a very structured system, and we're trying to put aircraft in line to send them in the same direction, to send them on their way. And if everyone comes off the runway in any which direction, it puts us in a really complicated situation, right in a part of flight that we want to be as predictable as possible. So.
Thanks. I'll kind of use my non-pilot analogy again on that one as I think of the Route 93, 128 interchange, and you have on ramps and off ramps, and they're all kind of congested together. And I know I drive that every day to go back and forth to work, and it's a nightmare. Very, very challenging with all the arrivals and departures off of the highways. And, I can just imagine that the importance of having a lot of structure from an air traffic arrival and departure perspective.
Yeah, just to add on to that one little bit there, Colleen, thank you. The analogy is great. The indoor and the outdoor, having traffic going against each other, going against the grain is never a good situation, whether it's in a car or in an airplane. So keeping everybody structured, going in the right direction and out the right direction, increases safety an unimaginable amount.
Okay, next question is going to be for Massport, and I'll let Flavio and Steve decide who's best to answer this one. We received a few questions about where community members can find specific information about noise levels in their town. Can you tell us about the reports that the airport produces?
Yeah, thanks, Colleen. I'll take this one. So all of our data, our annual data from the noise monitors is published in our environmental data report, which is accessible through the Massport website. Any event-specific questions about local noise monitors near people's homes, you can direct that to the noise abatement office, by filing an online complaint or calling our office directly, and we can research, specific aircraft events and noise monitor values that we observe during those events. We also have near live flight tracking available from the Massport website as well, so you can track individual aircraft, and we can give you noise values of those particular aircraft if people are interested.
Thanks, Steve. Flavio, anything you want to add to that?
No, well done, Steve.
All right, next question. I'll ask Barrett to start us off on this one. We're told runway use is influenced by wind direction, but what else determines runway use at Logan, and who decides which runways should be used?
So as we just touched on, other than wind, the runway configurations are influenced by demand. So the arrivals and departures any given hour, and the number of aircraft, like I said, that are coming and going to Boston. So our capacity, that total number of available slots of arrival and departures per hour, is what we're shooting for. Every runway configuration has its own amount of capacity that it can support based on the taxiway setup and the amount of separation required going into that particular runway. When it comes down to it, the tower, the TRACON, and Boston Center as well, we all collaborate when we're discussing, what runway configuration we're going to use for the day, depending on what's coming and what's going. But that final authority lies with the tower supervisor. They're the supervisors are the ones that make that decision in the tower to let us know what configuration we're going to be in.
Okay, thanks. And I know there's a pilot in command perspective, so I'm going to turn to Lee in a moment. But Barrett, I just wanted to ask you if you could further explain. You said tower, center, and TRACON. Can you just kind of tell us about what those are and I know that's where all the air traffic controllers sit, but they all have different functions, and there's a lot of them.
Yeah, so Boston Tower, obviously people know the tower at Logan. It's a beautiful, beautiful facility, and they all see it every time they fly in and out. Boston TRACON, where I work, is located in Merrimack, New Hampshire. We provide radar services to aircraft in and out of the Boston area up to, depending on the geographical location, 10 to 14,000 feet. We control anywhere from Laconia all the way down to the Cape and Islands, as far west as just east of Bradley, and then all the way up over Portsmouth. As far as the center is concerned, the center has, it's a large facility. It's where I started my career, has approximately 200 air traffic controllers, 5 different areas. They operate from Moncton, Canada, down to just north of Kennedy. They do all the high altitude stuff. So they're your jet traffic, your commercial traffic, the stuff that's moving fast. When you're getting from the East Coast to the West Coast, you talk to centers most of the way along the way. You start with the tower, then a trachon, then a center, and the reverse on the way back through.
Okay, and that's about how many people?
So for the tower, trachon, and the center for Boston alone, controller wise, you're talking probably somewhere around 350 controllers, lots of support staff, managers beyond that, technical operations who take care of all of our equipment in our buildings. I would guesstimate that you're probably talking somewhere between 500 and 600 people just in the greater New England and upstate New York area.
Okay, thanks. Okay, Lee, from an air carrier perspective, can you talk a little bit about the question on runway use?
So we work with the FAA, our Systems Operations Center. The dispatchers there will take the information in terms of the points that Barrett brought up, which configuration the airport is expected to operate in, as well as other conditions around the area that might affect which arrival or departure routes we're going to be using. We take that as well as weather conditions and put that into our flight plans, which the dispatchers then work with the pilots in terms of essentially how the flight is going to operate. I'd like to call on Ryan because he can certainly talk about sort of the pilot perspective, because obviously if there are circumstances or issues where the pilot needs to do something different than the flight plan, that's something that the pilot is going to work with the air traffic controllers on, and then make sure that our dispatchers know what the plans are.
Surely. Thanks for the question. From a pilot's perspective, about 250 miles out or about an hour away from landing is when we're really starting to prepare for our descent. We come up with a plan A, a plan B, and consider a plan C. Basically, as pilots, we don't like change. We like our plan A to work the entire way through our entire flight, so there's no different surprises. As far as a dispatch, a lot of things can change a runway change, or expecting something other than we planned on. So for safety, we really like to stick with plan A or plan B, but a lot of times, even at lower altitudes, we'll just be advised that there's a runway change. And a lot of time that means being vectored and pulled off this arrival, resequenced, which is an incredible amount of work for the air traffic controllers. And when those changes happen, usually it's due to weather. When we're selecting a runway to land, Boston, like we talked about in the presentation, has, I'll probably get the number wrong, but 22 different runways that we can land on. They each have landing weather minimums. So some of them get us lower to the ground and have better approach lights and different decision altitudes that we can get down to in order to see the runway. 3-3 left is a good approach to get down low. 4 right as well. If we're working on 2-2 left or 2-7, the minimums are a little bit higher. So that changes things too. So weather is definitely a factor when the visibility is, less than 2 or 3 miles and the ceilings might be less than 500 feet. So the dispatchers really work with us on the ground to get us up in the air. And then from there, we're relying on air traffic control if there's any changes. And it happens often. It's definitely one of the challenges of the job, but those changes are made safely and allow us to coordinate with air traffic control to make those changes and get on the ground in a safe and timely manner.
Thanks.
Mhm.
Thanks. That's very interesting, all the different perspectives on that question. Next question is for Richard. How is noise measured from airplane landings when the wheels touch down and speed brakes are deployed?
The FAA uses the computer model we mentioned earlier, AEDT, the Aviation Environmental Design Tool, to calculate noise on and around airports. And how the computer model works is you enter a tremendous amount of data about the airport and the flights and the weather into the computer, the exact position of the runway ends, on the earth, the weather data, all the flights in and out of the airport, the flight tracks using current radar data. and noise information from the aircraft manufacturers. And it essentially runs the airport in a computer model for a year. And then it can generate noise contours like a contour map, but not of terrain, but of the noise generated by the aircraft coming and going. And its greatest value, I think, is that not only can it calculate the existing noise, and you could do that in other ways, but one thing you couldn't do without the computer model is to forecast what would the noise be if a change was made. If you built a new runway or a runway extension, or if you changed flight tracks, or if one runway is shut down for a while because it's under construction. And that way you can look at future scenarios and see what the noise might be, and that'll help you make better decisions on how to minimize the impacts of noise on people when you have choices. One of the things that we're very lucky at Boston Logan is that Massport actually has a system of noise monitors. There's a few dozen of them, and they've been there for many years. Most airports don't have that, but I think the people living around Boston are lucky to have that long-standing system of noise monitoring at Logan. And there are a few airports in the United States that have that, and some of those systems are eligible for FAA funding. We just recently funded a small noise monitoring system at Burlington, Vermont.
Okay, thank you. Okay, the next question is around references the MIT RNAV study. So I'll try to cover this one. The question is, I thought the MIT study found an alternative to aircraft going over the North Shore to land on runway 22 left. What's the status of that? So as I mentioned earlier, FAA has been working with Massport, and MIT has developed a number of recommendations that they provided to the community group, the Massport Community Advisory Committee. And one of those recommendations was a shift, was an alternative procedure, RNAV procedure, that shifted a majority of flight tracks coming into Boston Logan, runway 22 left, from overflying the North Shore communities, of which I am one of those community members. I live on the North Shore, and taking those flights and being able to shift them over water. That procedure was accepted by the community group and moved forward to Massport and FAA. And FAA is currently in the process of evaluating that procedure, doing the design work, the environmental assessment, and getting that hopefully published before the end of the year. So significant amount of work goes into changing the procedures. I think sometimes it's the impression by the communities are that it's, a simple process just to change a procedure. It is very, very complex. There are a lot of interactions, as you saw on the procedure boards we showed earlier in this workshop. And all of those interactions need to be considered, as well as the design process in ensuring that ultimately the new procedure is safe. So I'm going to just ask Veranda if maybe she could speak to the environmental aspect of that procedure.
Yes, right now we're viewing the runway 22 left RNAV procedure. We follow the NEPA process, which is the National Environmental Policy Act of 1969. NEPA requires federal agencies to use an emissionary approach to planning and decision-making, propose action to develop, and may adversely impact the environment. NEPA requires a process established incorporating public involvement and integrating the requirements of other applicable environmental laws and regulations into the federal decision-making and planning process. This requires the FAA to evaluate the environmental and related social and economic effects of a proposed action and provide opportunities for public involvement where appropriate. For air traffic procedures, FAA first conducts an internal preliminary review of any potential environmental impacts, including a noise screen assessment. And then based on a preliminary screening, the FAA then determines the appropriate level of NEPA review. The 3 levels of NEPA review are a category exclusion, which is also called a CADX, an environmental assessment, EA or EIS. For the runway 22 left RNAV, that was a category exclusion. So that has been reviewed and is currently in the process, hopefully for implementation, as you said, Colleen, that by late this year.
Okay, great. Okay, next question. Will the workshop discussions, questions, and responses be documented for future reference by the public? So yes, they will be. This workshop is being recorded, as will tomorrow's workshop, and you'll be able to access those on the FAA YouTube page. And I'll just give you that website. It's YouTube, www.youtube.com/@FAA news/streams. So @FAA news, all one word, /streams. And my understanding is the recording from today's workshop will come up very shortly after we complete the workshop. So there is not much of a delay. Okay, the next question it's got a couple parts, and I'll tag team this one with Barrett. So part 1, does the FAA acknowledge the public's requests that airport operations be changed to significantly reduce concentrated noise created by RNAV/PBN, and that the FAA's public engagement necessitates action to relieve the noise burden caused by the RNAV/PBN, not simply educational discussion of the complexities of airspace and associated operations? That's part 1. Let me just read part 2. What directive from which authorities would be required for FAA to develop timely solutions to the repetitive noise created by implementation of RNAV/PBN to produce substantive relief to those living under the concentrated flight paths? Okay, so that's a mouthful. So the first part of the question, does the FAA acknowledge the public's requests that airport operations be changed to significantly reduce concentrated noise? So I would say absolutely. The FAA works hard to listen to communities and do what we can in order to address the concerns that are raised. We have a number of community engagement efforts. I mentioned one of those, working closely with Massport, MIT, and the Massport Community Advisory Committee on the RNAV study, which looked at alternatives that could be implemented that would reduce the impact of aviation noise on communities, yet maintaining the benefits of both efficiency and safety that PBN brings to the national airspace system. So that was a significant effort, started in 2016, and is still, we're continue to work to implement community requested procedures there. So there is, that's one aspect of FAA's community engagement. I would say another one is the noise portal. So we have an online system that you can get to by going to www.faa.gov/noise, and that will take you to a number of resources, both educational resources. It identifies the significant amount of research that FAA is involved in, as well as opportunities for individual citizens to submit questions and concerns. Every question that is submitted into that portal will receive an answer. So if you have a question, we will get you an answer. So I really encourage folks to utilize that tool. So those would be a few examples. The second part of the question around what directive from what authorities would be required for FAA to develop timely solutions to the repetitive noise created by the implementation of RNAV. Over the last 40 years, FAA has been working to reduce the number of Americans exposed to aviation noise around airport communities. Addressing this concern requires collaboration among FAA, air carriers, airports, aircraft manufacturers, research universities, other stakeholders, which include industry partners, local communities, and elected officials. And we acknowledge that there are very often requests made by the community that cannot be accommodated. And that's in most cases are based on safety criteria and the complexity of airspace or numerous other factors. So as I stated earlier, I think the current community engagement strategy with FAA is an area that has made significant move forward in recent years. And you know, we work hard to reduce the impact of aviation on communities. So I'm going to turn this over to Barrett now, and you see if Barrett, and then maybe also I'll see if Flavio has anything to add on that.
Thanks, Colleen. Yeah, just from an air traffic perspective, you know, we are always trying to upgrade and make positive changes to the airspace system. You know, anytime we try to develop a procedure that's going to have any kind of change to the environmental impact, the users, the communities, everyone is involved in that process to see what the possible outcomes could be and what the benefits would be. So that there's a lot to that process. We don't just change procedures to change them. You know, we go through a really stringent process with our users. But for us, it's all about the predictability. The PBN RNAV procedures create predictability, and sometimes that predictability is not good for other folks. You know, so it's trying to find a happy medium there of what's the best case for the users, for the environmental impact, for the operator, and for air traffic to maintain that safety aspect that you've talked about. It's the most important thing that we deal with in air traffic is the safety of the operations. We can't waver from that. That's what we're here for. So it always comes back to that.
Flavio, any perspectives from Massport?
I would simply add that we worked very closely with the FAA and the communities during the whole RNAV application and rollout. We did. We were successful to convene the MIT study, which is unique in the country. Many of my colleagues call me up and ask me about it and want to replicate it. So we did a lot of work with the community, and it provided a lot of community opportunity for input. And the solutions, some of them are relatively easy when it's over the water, and that was tough because they eventually have to go over land in the South Shore. But it's much more difficult challenge when it's over land, and I think we worked very hard at it and tried to get some possible options for solutions.
Thanks. And I just wanted to also add that I know when we talk about timeliness, you know, that was part of the question. It's the process to change a procedure is extremely complicated and time consuming. And not only is, you know, the one request at Boston, that has to be integrated with many other needs within the national airspace system across the country. So Boston does not work in a vacuum, right? We have to be concerned with not just how will that procedure interact with the airspace and other procedures, but also how is that procedure implementation prioritized amongst all the other procedure changes that are needed across the country, with the limited amount of technical resources that are available in order to do the design work, do the environmental work, do the flight check work that needs to be done for every procedure. So it is complicated, and I don't say that to use that as an excuse, but I think just to better explain that it does take time. Okay, next question. is, I'm going to ask Barrett and Flavio to cover this one. Why has there been such a large decrease of runway 27 departures over the past 10 months? I'll let you guys decide who goes first.
So for, I guess I'll jump on that. Thanks. So for a air traffic perspective, anyone who's from the area of Boston or drives into Boston can constantly see cranes working to build buildings and expand things in the city all the time. For the last couple of years, we've had some very large cranes that have penetrated the runway 27 departure corridor. And it's been going on for a while, and it's going to continue going on as Boston expands as a city. It's part of the construction nature. When visibility at the airport is less than 3 miles, or clouds, as we talked about, the ceilings that Ryan talked about before, are less than 1,000 feet, the aircraft that are departing runway 27 are required to climb out at a much steeper angle to safely miss those cranes because they can't see them. And a lot of aircraft, unfortunately, can't meet those climb out criteria, so they have to use a different departure runway, end up on 3-3 left or 2-2 right or left, depending on the size of the aircraft, to make their departure so they can make those climb outs correctly.
And I can simply add that there has been some changes in some of the recently in some of the cranes. There has been one crane that I think recently came down, and that may change some of the impacts. But I agree with Barrett that there's a lot of activity downtown and in the South Boston waterfront with cranes, and that has had some type of a short-term operational impact at Logan.
Okay, next question. You mentioned the Block 1 and Block 2 changes. At this time, following the MIT study, what is being done to relieve the negative impacts of aviation for those of us under the narrow flight path, 33 left, to the west? During Block 2, MIT did make a recommendation that would have provided greater dispersion, but that was rejected by the communities. So at this point, there is no additional work being done to study that runway departure. Okay, next question also for me. May attendees get a copy of the PowerPoint slides? So as I mentioned earlier, the meeting is being recorded and live streamed on YouTube, and that recording will be available shortly after completion of today's workshop. And as a reminder, this is an informational workshop with an opportunity to ask subject matter experts questions about Boston area airspace and operation. The questions asked here are not comments on proposed projects. And if you have a specific noise complaint, you may submit it to either the Massport Noise Office, as Steve Soprizio mentioned earlier, or the FAA Noise Complaint Portal, which I covered. So all of the slides that we showed earlier, those are part of the recording, so you can view them after through that recording. Question for Barrett. We received a question about why runway 27 is used for early morning and late night flights, which sends planes over growing populations. Barrett, can you talk about runway utilization during these times?
Sure. So just as we've talked about many times so far, runway selection, runway utilization by air traffic is based on a large number of variables, mostly based on wind and demand. We do try to use runways that don't impact our neighboring communities early in the morning, late at night, during the overnight hours. We understand that that's our part in this whole plan. But sometimes it is out of our control. If there's runway maintenance going on, or a runway is closed, or if there's different things happening as far as the weather's concerned, and also based on our demand. Sometimes first thing in the morning, we get a large arrival bank and a large departure bank at the same time. We're trying to get passengers and airlines on their way and to their destinations as quickly and as efficiently as we can. And it does end up forcing us into using runway 27, sometimes in those early morning hours and sometimes late at night. But we understand the impact that it does cause, and we do try to stay away from it as much as possible.
Okay, next question. I'm going to ask Ryan to kick us off on this one. Why do pilots have the option to choose their route as opposed to mandating the overwater approach, especially for overnight flights?
Maybe a little more clarification. I very rarely get to choose my route on the flight. It's usually something that's filed. That's done by dispatch on the ground in coordination with air traffic control, kind of like what we talked about earlier, as far as what runway we're going to depart from in one runway airport and then landing on another. Usually late in the evenings. My experience flying into Boston at night, usually we're landing runway 22 or runway 27, which definitely puts us out of the water. You know, but really it's back to the same thing Barrett's been talking about too. It's primarily what wind direction and what runway is suitable for visibility and ceiling requirements in order to land at that airport. I hope that helps.
Thanks. Barrett, anything to add to that?
Sure, just to add on to what Ryan was saying, it's very rare that in and near a large airport that a pilot gets to pick what route they want to fly or choose, you know, how they want to get in and out of that airport. Again, we talk about predictability. We like to keep the airplanes in line as much as possible because they all got to go to the same spot. Everybody's landing on the same pavement. As far as when they get up at higher altitude, though, that's a different situation and probably not really what the question's focused on. But at higher altitudes, generally, aircraft can fly more point to point based on the winds. If you look at when planes are going over to Europe and back and forth to New England, we have different tracks they can select from based on winds on any given night. They can select from one of those tracks so we know which one they're going to be on. So that's more of a high altitude thing. We don't deal with that here locally in Boston. But as Ryan was saying, for the most part, air traffic assigns a particular route and it's a sitter or a star, and then the air carriers follow that.
Okay, so let me see if I can, I'm going to ask, I'm going to go off a little bit here. So again, starting with, I'm not a pilot. So if a pilot is given a certain route or runway to land on, and for some reason they don't feel like that's a good choice, and they say unable, what happens at that point?
So a good example of that would be springtime weather, right? When we have thunderstorms moving through the area. And so a lot of times air traffic control, if there's a line of weather that is closing down a specific route or an arrival to an airport, they might bring us in through a different direction, which is not a normal flow, to get us around that weather and into the airport. If that hasn't happened yet, we can go off script, so to speak, and I would request with an air traffic controller, I would ask for a deviation for weather. And so basically at that point, I'm asking for a heading because I can see the weather, whether it's outside or on a radar, and that I can stay clear of that. And then that removes me from the arrival route that's been filed. And then once I'm around that weather, I'm then given a fix that is farther down the line that was on that original route that I can then turn to and then resume the arrival. So there is some flexibility in pretty much weather operations that I can come off of the arrival procedure. But then as soon as I'm clear of that weather, the expectation of air traffic control is that I'm going to come back onto that highway, so to speak. If you're talking about ground-based GPS in cars, if somebody's using Waze or something like that, right? So it's going to pull me off to get around weather. I'm going to pull myself off, but then I'm going to get routed back on the original routing just farther down line, if that makes sense.
Great, thanks. Barrett, anything you want to add to that?
Yeah, just from an air traffic perspective, you know, if a pilot's come back to us and they say, hey, I can't take that runway you've assigned. I need 3-3 left. Like I can't take 2-7. Generally speaking, it's an operational need. It's the aircraft's too heavy. The wind component is too much of a crosswind for that type of aircraft. Maybe the runway's too short, you know, and there's a lot of situations that can occur that a pilot in command is going to say, I need this for operational reasons for me to maintain safety of this aircraft. We work with them, we assign a new runway, and we sequence them in to make it work. So it happens, it does happen quite often. it's a regular thing. It's not out of the ordinary, but it is something that we work around throughout the day.
Okay. Next question, Barrett. You might want to take a drink of water. You've been doing a lot of talking. There was no discussion of runway 27 departures. Can you provide a similar reporting as was done for runway 33 and northwest winds for runway 27, please?
All right. So talking about runway 27 departures, just like any other departure that comes off of Boston, they follow prescribed procedures. We have SIDs that are dictated by both legal requirements and community input. The community has had a huge input into how we operate with these departures coming off the runway. Since runway 27 departures were addressed in other configurations, it's rarely used as a single runway operation. We don't normally arrive runway 27 and depart 27. It's a very low capacity situation. It may be something that happens during a storm, but generally speaking, we try to stay off single runway operations for the most part. So that's why I wasn't presented as much detail as runway 33 left, to be honest.
Okay. Next question is for Veranda. My name is Christopher Elliott, and I chair the Hanscom Field Advisory Commission. I'm concerned about the impact of aviation on global warming. The UN is saying that the world may pass an irrevocable climate change tipping point by 2030. My understanding is that Europe is outspending the US by 10-to-1 on climate-friendly aviation technologies, which puts us on a path to have no aviation industry in the future. Shouldn't this country be doing more to transition to climate-friendly aviation, both to protect the planet and also to remain competitive with European aviation industries?
Okay. At the United Nations Climate Change Conference in November 2021, U.S. Transportation Secretary Pete Buttigieg released the U.S. Aviation Climate Action Plan that sets out to achieve net zero greenhouse gas emissions from the U.S. aviation sector by 2050. Because transportation produces the most emissions, the U.S. DOT and FAA need to be a large part of the solution. This ambitious but achievable action plan will create a sustainable aviation system that the United States is committed to. The U.S. will also work with international partners to maintain and strengthen the carbon offsetting and reduction scheme for international aviation. More information about this can be at the FAA website, faa.gov/sustainability.
Okay, and I'm going to ask Flavio, maybe you can jump in. I know in the video, Lisa talked a lot about the work that Massport is doing around sustainable aviation. And I know there's a couple items that maybe you'd want to touch on there.
Sure. Thank you, Colleen. As you may have heard, we've launched Massport Net Zero 2031, which is our lead action to reduce our carbon footprint for all our Massport facilities. So that would include Hanscom. We have, based on the protocol that's used when you do these things, you can subdivide your emissions 3 categories: Scope 1, Scope 2, and Scope 3. Our commitment is that the Scope 1 and Scope 2, which is ones we directly control, that we will get those to zero by 2031, and keep working on that beyond that. On Scope 3, which is more coming from the aircraft engines and other things that we don't control, we're working very closely with our partners. I have many programs trying to target those Scope 3s. For example, at Logan, we have a program on the electrification of ground service equipment. We also have a program across our airports regarding EV charging stations. As Lisa mentioned on the video, we're working hard with the industry on sustainable aviation fuel. So we have a lot of plans to keep pushing that level of it as well. Thank you.
Thanks.
Colleen,
And,
if I could
Lee.
add something, just as Flavio mentioned, the understanding what we're looking at in terms of global warming, most of the operators are setting their own science-based emissions reduction targets. JetBlue has committed to reduce the well-to-wake life cycle scope 1 and 3 greenhouse gas emissions related to jet fuel by 50% by 2035. And most of the other operators have very similar goals. This is a multifaceted partnership that we're all looking at, from global warming and emissions reduction. SAF is a very big part of our strategies, and we are at JetBlue looking forward to working with Massport on getting more of that in the Boston area.
Thanks. And I know I'm sure everybody on the panel could talk a little bit about this, but Heidi, anything you want to add on this?
No, completely agree with Lee. I think each of the operator communities, whether that be the airlines or GA, are all looking at ways we can be the better neighbor and help in terms of being sustainable and implementing sustainability programs. SAF is a key one for business aviation as well. So we're in the same boat there, looking to work with all of our airport communities to make sure that's available.
Okay, we'll move on to the next question. Has rising demand given any indication that more flights could be moved from Boston to Worcester? And maybe Lee or Flavio, you could touch on those, one of you?
I can start, and we'll love Lee to weigh in since she's flying out of Worcester. We definitely are working very hard at Worcester. We have been operating it for many years, and then we took ownership of the airport. We've invested with the FAA's support and help on grants, significant dollars in that airport, over $100 million. Lisa mentioned the Category 3. Worcester is challenged by weather. We worked very hard with the FAA to put in the Category 3 ILS system, which allows you to fly in the worst weather conditions. So as you all may know, dependability is critical to the success of airports. So we're all in on Worcester, and we're working very hard. And I want to congratulate our airline partners of JetBlue, Delta, and American. We struggled during the pandemic, particularly these smaller airports, to return to service. And I have to say, they brought it back, and now we even have more service. So I think we have a very good story to tell, and we'll continue to invest at that airport.
Thanks, Fabio. I mean, I think we, as I mentioned earlier, we and other airlines do this as well. We are constantly looking at our networks, looking at where the demand is, what our customers are interested in terms of where they want to fly, and then also looking at what the diversity of our fleet is and how well we can apply that to support multiple communities. So it is something that we are constantly looking at, and very happy to work with Massport.
All right, thank you both for that one. Next question. I'm gonna ask Barrett to start us off on this one. And I'm probably going to mispronounce some of these waypoint names. So my question refers to KBOS, Northeast departures, in particular, Blazer 5 departure. When departing runway 4 right, why are aircraft routed directly over the Point of Pines neighborhood at Nahant, and Nahant being the waypoint name, Nahant intersection, as opposed to a point over the water approximately 1 mile earlier and turning towards Herbie intersection without any effect to any neighborhood or other air traffic? How do we get that procedure reviewed at both FAA and Massport?
First, Colleen, that was excellent reading of those. I really do appreciate that. So if everyone can remember from our storyboards, when you looked at the 4 right and 9 configuration, there was lots of blue coming off the airport, and everything was kind of lined up and set. So you come off 4 right, you come off 9, you come off 15, sometimes 4 left. It's a really, really complex area in that configuration. There's not a lot of space to work, to be honest with you. So those 4 right departures, And when they turn to Nahan, it's based off them being separated from our runway 9 departures. We need to keep them separated all the way out until they get a little bit of altitude under them. Then we can start mixing and matching as planes need to go to the north or south. It's just, there's a lot going on right there. So we really are restricted by the other runway departures and in maintaining a safe separation standard between them. Turning any earlier would reduce that required lateral separation that we have to have between those departures, and any safety buffer that we've built in would just disappear.
Yeah, so I remember working with MIT on some of the proposed RNAV changes, and there being, I'm not sure this is the right word, but boundaries, airspace boundaries. Is that what you're referring to? When you
No, so the airspace boundaries would be more of like how we sectorize the facility. We break up the airspace to different controllers while we're working. But as far as the protected boundaries, I guess you could put a bubble along on particular route and say, I've got to protect on either side of it this much airspace. So I guess you could call that a boundary. It's the same idea. They're just fake lines in the sky. You know, nothing on the ground depicts what we're doing, but it's how we separate it in the sky.
Colleen, I can also add a little context from the community perspective. Close into the airport, you have 2 community neighborhoods of Bayswater and East Boston and Winthrop. And if we turn those too early, then you're overflying communities that are even closer to the airport when the aircraft is lower and louder. So we have to kind of thread the needle as well to make sure that whatever we do is not too impactful while the FAA tries to meet its safety parameters.
Okay, next question is going to be for Steve Soprizio from Massport. Is the map on the Massport website, and I have a website here, massport.com/logan-airport/about-logan/noise abatement/monitoring. Is that up to date with noise monitoring listening stations? And if yes, why is there not a noise monitoring instrument placed directly under tech being in the waypoint off of runway 33 left departure? The one currently listed is placed at Magoon near Thatcher, which is north of tech, meaning that the planes turning south and west, ? Are not being monitored.
Yeah, thank you for the question, Colleen. So that is the accurate location of the Medford noise monitor. We do have 30 noise monitors placed around Logan. That is one of them. And, you know, sometimes it's difficult to place the noise monitors exactly where we want them. We have to, you know, put them in locations that, you know, we can find to place these. These noise monitors also have been in place for decades before that tech waypoint was established. So it still is recording aircraft noise. You know, we correlate flights at that noise monitor using that noise monitor. So so there's basically a couple of reasons why it's not directly, you know, under that waypoint. We do have abilities with our software to use virtual noise monitors as well, so we can actually place noise monitors wherever we'd like, and we can model noise output at those locations. So we have a couple different means of accurately estimating noise values under any particular point. Hopefully that answers the question.
That's good. Thanks. Okay, next question. I'm going to ask Lee to start us off there. Why are more and more flights taking off and landing in early morning hours when they disturb people's sleep?
Well, obviously the intent is not to disturb anybody's sleep. As we've talked about earlier, a lot of the schedules that we have are based on market demand and where we see interest in providing service, and that really becomes a very big driver. If there isn't interest in the schedule and the flights, we certainly hear back from our customers on that. But we also, you know, will work closely with air traffic and Massport if we need to consider adjustments to the schedule.
Fabio, anything you want to add to that?
Just that Boston is an origin and destination market, meaning most of our traffic is origining or ending here. And we've been like that since the beginning of time. And so we pretty much follow the commuting pattern of what Boston residents and people want to come here to do. So we've had that for many years. I mean, like I said, from the beginning of time, we've been an R&D airport versus like an Atlanta that's got a lot of connecting traffic. That's really, people aren't getting off the planes other than to go to another plane. So that's just the baseline of our market. We have worked very hard over the years to minimize impacts, and we've talked about all those during this call. We've have experienced a recovery from COVID. So during the COVID period in 2000 to 2021, we've had big drop in traffic, and now we're recovering from the COVID impact, just like the rest of the economy, and all of us are recovering. And so some of that traditional pattern of a morning and evening kind of commuting pattern has returned.
Okay, thank you both. Next question, I'm going to ask Barrett to kick us off here. What caused the large increase in the use of 33 left runway in the summer of 2022? And when will this go back to more normal levels?
So I'm going to go ahead and tie this back to our why are we not using 27 so much question, because it's really relative. The cranes in the city obviously are impacting the use of runway 27 for a departure runway. So when we're in a northwest configuration, the alternative is to just depart off runway 33 left. As Flavio stated, those cranes do go up and down, projects come and they go. So that fluctuation of runway 27 usage or runway 33 left usage is going to do the same. It's relative to what the impact is out there from the construction.
Flavio, any other thoughts there?
No, thank you.
Okay, next question is for you again, Barrett. On a northwest departure configuration, why is it, sorry, it's worded funny here, why it happens that in the morning you use both runway 27 and 33 left, but once you switch around noon, you will only use 33 left until the end of the day? What is the reason behind it? This involves having 430 plus planes flying over tech, which, as you can imagine, is a massive noise problem.
So when we are in a northwest configuration and it runs from morning to night, depending on the winds, obviously, we have an arrival volume in the morning, which is much lower. Our departure bank first thing in the morning, planes getting out, as we talked about, Boston is a origin and destination airport. So those first departures going out to the West Coast or going down south of Florida, there's a lot of those versus the arrivals that are coming in first thing in the morning. They tend to be more spread out. So because of that, we use 27 as the primary departure runway because there's not as much volume coming in. So we can use a smaller runway. It tends to be smaller aircraft. Runway 33 left, all those heavy loaded aircraft, people heading to the West Coast, they need to use a long runway. 33 left's the departure runway. Now, as we get to the afternoon, that tends to switch. Our arrival demand kind of flip-flops. Sometimes it evens out. But when we go to a 2733 configuration, it allows us to add runway 32, which is a smaller runway, but we do have a lot of aircraft specifically from JetBlue when they're flying their Embraer 190s, the BCS ones, smaller jet aircraft, more regional type aircraft, and some of our corporate partners can use that runway, and it allows us to have a higher arrival capacity in the afternoon, because that's when the meat of our traffic, that 1 to 4 o'clock range where everyone wants to sleep in at their hotel and then fly in the afternoon to get home. They don't want to get in too late, or they want to sleep in at their house and depart a little bit later in the day. So all that demand causes us to go to that 2733 left and adding 32 configuration. And that's why we end up with the runway usage the way it is.
So market drives, it doesn't necessarily drive the runway configuration decisions, but it drives when airplanes are wanting to come to Boston and leave Boston.
Absolutely. And that the capacity component is the big component about what we use as far as runways are concerned, weather, wind, aircraft performance, but the capacity, trying to figure out what we need to make it work so that we are not unnecessarily delaying our passengers and our airlines. That's what it comes down to.
Okay, next question is for Veranda. How does the health and well-being of residents on the ground under the narrow RNAV flight paths factor into your operational decisions? The navigation system has been updated with RNAV, but we're using pre-RNAV noise policies and metrics, including the 65 DNL metric. These metrics do not accurately represent the impacts of repetitive noise we're suffering under the flight paths.
Okay. The FAA models aircraft noise using an annual day-night average sound level DNL metric. Significant noise is defined as day-night average sound level of 65 decibels or higher. The DNL metric is a single value representing the aircraft sound level over a 24-hour period and includes all the aircraft sound generated within that 24 hours. The DNL metric includes a 10 decibel weighting for noise events between 10 p.m. and 7 a.m. This weighting helps account for the greater level of annoyance caused by nighttime noise events. The metric essentially equates one nighttime flight to 10 daytime flights. In addition, the FAA is reviewing our noise policy as part of our ongoing commitment to address aircraft noise. This effort builds on our work to advance the scientific understanding of noise impacts, as well as development of analytical tools and technologies. The noise policy review is evidence-based, thorough, and collaborative. We are considering findings from ongoing noise research, including the Neighborhood Environmental Survey, which provided an updated noise response curve, and other research related to health impacts, speech interference, sleep disturbance, and economic impacts. We examine the distribution of environmental risks, trade-offs, and resulting impacts across communities. So those are things that the FAA is doing to address the noise. Thank you, Colleen.
Thanks. And so I'm going to go back a little bit to the question. I just want to add one thing. So the question says we're using pre-RNAV noise policies and metrics. So Veranda mentioned the noise policy review. I know there's been a lot of questions around from community members on when will there be an opportunity for community participation in that review. I just wanted to mention the website, faa.gov/noise policy review, all one word. If you go to that website, that provides the most up-to-date information on that review and is updated regularly with progress and opportunities for community engagement. So I encourage you to go to that website and subscribe. You can put in your email address and you can get notified when there's changes. So that's a great resource, and encourage everybody to sign up for those emails, because that is very much a current important activity that's going on right now, is looking across all of FAA's noise policy and identifying potential opportunities for adjustments. Okay, question for Barrett again. Barrett mentioned structural limitations and larger transatlantic planes that have more fuel and require a longer runway than need to use 33 left for departure. Do these also factor into determining which runway will be used? He did not mention these in the question directly related to runway use determination.
So as far as how we determine what configuration we're going to be in, the specific aircraft's need is not necessarily taken into consideration. We look at the arrival and demand, the weather that's impacting the airport, whether it be wind or other weather phenomena, and any runway construction, like we talked about, taxiway construction. Now, their need based on an individual pilot's request does impact that specific aircraft's runway that they might use. You know, so if we're in a 2722 configuration, or I'll try to change it up. Say we're landing 27 and we're departing 33 left, and aircraft comes over and says, I'm too heavy for 27, requesting 33 left. We're going to put them on 33 left for operational need and for safety purposes, but it's not impacting our actual configuration. So again, it's really related to that singular aircraft and that pilot in command making that decision of what they need. Now, we think of like the A380, which is the largest aircraft flying in the world today. That has very limited ability to land on particular runways and use certain taxiways, especially at an airport like Boston Logan. So we have to we have to take that type of thing in consideration. If we know we have multiple A380s coming throughout the day and we're having winter weather operations, that may impact our decision-making process, but it is not the one factor that makes us decide which runway we're going to use for any particular configuration.
Thanks. Okay, next question is for Richard and Barrett. And let's see, I'll ask Barrett to start us off and then shift over to Richard. The noise and pollution over parts of Cambridge are unbearable. We need to reduce air traffic over these areas and disperse it. What can be done?
Well, so right now, I would say the biggest impact to Cambridge would be the runway 27 departures. That goes right out over the city and turns towards the southwest and puts it in that Somerville, Cambridge area. So it definitely is impactful. We understand that. Other departures, if they're coming off 3-3 left and end up departing towards the south, heading out over the Cape and Islands before they transition into the inroad airspace, those could be impactful as well. But generally speaking, they're higher up at that point, so there's less of a noise, and I would assume a pollution impact either. As far as the overnight operations, we do take into consideration the impact that we have on the communities. We have a plan in place during our nocturnal hours, which are our lower arrival and departure demand hours, where we arrive over the water and depart over the water. So we do an opposite direction operation. So we do reduce our capacity. We do increase separation between the aircraft in order to help alleviate some of that noise and pollution concern that our surrounding communities do have.
Okay, Richard, so I know Veranda mentioned earlier this 65 DNL. Can you talk a little bit about noise contours and challenges with noise mitigation?
Sure. I just glanced at the most current noise map for Boston Logan for the year 2020. The Congress directed the FAA and a group of federal agencies, including HUD, EPA, the Air Force, and perhaps others, in 1979 to develop a way to calculate noise around an airport. They also directed the FAA in that same statute to determine a level of significance of noise. And the agencies got together, and those both of those directives were finalized in the mid-'80s, and had identified the 65 DNL as the noise metric that is significant noise. And nobody actually hears DNL. That's the trouble with a noise metric. What people hear is the loudest thing that they hear, or they'll hear it for a certain duration of time as the aircraft goes overhead. But when the federal agencies got together to determine what's the best way to figure out a noise metric that takes into account all of the noise events, both the maximum level of event, the duration of the event, and how frequently they happen, it wasn't as simple as people thought. I think people living around airports become very focused on nighttime noise or the maximum noise, understandably, because that's what you hear. But to be able to assess the noise impacts of aircraft, you need to factor in all the noise, how loud it is, the duration of it, how frequently it happens, and the noise throughout the day, whether it's daytime or nighttime. So that 65 DNL noise metric was created in the mid-'80s. And I think at the time it was a very good standard. I think the agency now has had plenty of feedback from the public that perhaps it's time to reassess that. And the agency is just starting that process now. I can tell you from looking at the noise map around Boston Logan, the 65 DNL contour does not get to Cambridge. So there would be very limited opportunities for the FAA and Massport to use significant noise as a reason to change what we're doing now. There are people living much closer to the airport who receive much higher levels of noise than anyone living in Cambridge.
Thanks, Richard. Okay, next question. I'll start it off and pass it off to Veranda. How can noise be reduced for areas north of Logan? So here we're talking about the North Shore. I talked about this a little bit earlier with the runway 22 left, RNAV, arrival procedure that's currently in development as part of the Boston MOU, FAA Massport MOU, and RNAV study. MIT made a recommendation to allow a shift of air traffic coming into runway 22 left from overflying North Shore communities and shift that out for a significant amount of time over the water. That procedure has been accepted by the community, proposed to or requested to FAA for implementation, and we're currently in the process of designing the procedure and doing the environmental assessment. So this would be an example of the ability to use PBN technology or RNAV to shift traffic away from populated areas. So I know some of the questions today focused on the negative impacts of PBN. I would just contend that this is an example of being able to use that technology to shift traffic away from populated areas. So with the precision of performance-based navigation, that precision in technology allows you to potentially make changes that really benefit communities. So to get specific to that procedure, Veranda, can you just touch on the status of the environmental analysis?
Yes, the for the runway 22 left, for the NEPA process, what we do, for air traffic procedures, FAA first conducts an internal preliminary review of any potential environmental impacts, including noise screening assessment. So that project was, we did a noise screening assessment, and for NEPA, based on preliminary screening, the FAA determines the appropriate level of NEPA review, and those 3 levels of NEPA review were the category exclusion, environmental assessment, or environmental impact statement. For runway 22 left, it was completed with the category exclusion, and the publication date will be slated for the end of this year.
Thanks. And I'm just going over in my head what I said, and I might have said runway 22 left departure procedure. I didn't mean that. I meant an approach procedure if I said departure. Okay, so for the panel, we have a few more questions to go. We're going to keep going for about another 15 minutes so that we can get them all answered. We won't take any more new questions, though. We'll just finish up what we have in the queue right now. Okay, so this one's going to go out to Barrett and Lee. With increase in precision during arrival and departure, it's narrowed the flight paths, which concentrates noise over specific areas. Can that precision be used to create more paths which will disperse the noise?
So from the air traffic perspective, with the amount of aircraft that are concentrated in the greater Boston area and the surrounding airspace at any given time, it's not really possible for us to disperse and fan out aircraft all over the place. It's impossible for us to do that right now. In simplistic terms, if you think about it, when you look at one of our boards that we've shown you today, and you look at a departure procedure, with the volume and complexity we have in and around Boston, there could be an arrival on either side of them, and that works going the other way too. You know, if you're looking at an arrival procedure, there could be departures that are coming out on either side of that aircraft. So it's the very tightly woven airspace that is based on predictability. And that's what we've touched on a lot so far today is from ATC's perspective, that the precision of these aircraft flying on these predictable routes that are all based on satellite navigation, that is the essential safety key to us being doing our job well. And it is hugely important to the operators, both the airline operators and the airport operators, during critical phases of flight. So both when they're arriving and departing. That's the most complex phase of flight in and around the airport, whether you're arriving or departing. We need to make sure that we give them predictability as well, so it reduces the workload on their flight crews, so we can ensure that that safety margin that we're creating is going to stay there and going to be maintained.
So I want to hear a little bit from a pilot and instructor perspective. Maybe Lee or Heidi, could you guys jump in and give me your perspective?
I think Barrett described it fantastically. I guess the thing I would add is on the arrival side, on the approach side, the importance of a stabilized approach is extremely important to the safety of the flight. And that's what we've been able to do with the new PBN procedures and approaches that are being designed, is to make sure that we can have that stabilized approach on arrival. And I'll toss it to Heidi, but Ryan may also have some comments as a pilot too.
Yeah, Lee, thanks. I couldn't agree more. I think the ability to perform that optimized descent profile and take advantage of the capabilities on your flight deck and the avionics in your aircraft to do that just adds to the layer of safety. And Barrett was so right. You know, your landing and approach is such a critical phase of flight when I mean, you're fine-tuned, and as much predictability that you can have in that phase of flight, it's really important.
Okay, moving on to Massport question. Does Massport have a zero emissions goal at Hanscom, and does this include aircraft emissions as well as land facilities?
Thanks, Colleen. As I mentioned earlier, and I'll highlight it in Lisa's video up front, we do have a comprehensive net zero program to get Massport down to the net zero by 2031 for emissions we control, or the scope 1 and scope 2 emissions. That does include Hanscom. Obviously, it's one of our key facilities. And so our effort is across the board, both on our buildings and on our equipment and on our rolling stock that we have, and some specialized equipment. Regarding the scope 3, which is emissions that we don't control, we're working hard at influencing our key stakeholders and putting in the infrastructure where we can to facilitate that and to work with the industry on sustainable aviation fuel. So it is part of our plan, but obviously that's out of our control on the scope 3, and we work hard. We're going to be working hard on how to continue that effort.
Okay, thanks. So the next question is for Barrett, and I'm not a pilot, and actually I was wondering this myself. Is there a wind speed below which the wind becomes irrelevant and any runway can be used regardless of wind direction?
So the very simple answer is, generally speaking, yes. Wind less than 5 knots is considered calm as far as most pilots and the airports are concerned. Has very little influence at that point on runway selection. So in those cases, we really focus on capacity, you know, what we have as far as arrival and departure demand, as we talked about, weather around the airport. If you live in this area, you know how the thunderstorms work in Western Mass and roll into Massachusetts out of the Berkshires throughout the summertime, and they pop up and they impact our routes and our departure selection really rapidly and on a continuing basis throughout those days. The only place that it doesn't really impact, though, as far as the wind speed, is when we're working around nocturnal procedures. So when we're departing 15 right and arriving 3 left, and as I talked about, in an opposite direction operation overnight, wind speed, we really don't consider it much there. Or I'm sorry, we don't consider the capacity and demand. We ensure that we're trying to provide the quietest operation for the surrounding communities overnight as we can.
Okay. Next question is for, let's do Richard first. Is there a way to convert from measured noise values, kind of, I would say, but similar to what Flavia was talking to us and Steve about noise monitors? Is there a way to convert from measured noise values and predicted AEDT values? Can these values be overlaid on a map?
I think theoretically, yes. What the noise modelers have told me in the past is you would need hundreds or thousands of noise monitors around an airport covering a very wide area to be able to develop a noise contour map like the computer model does. So even though Massport has a large network of about 30 monitors, it's not enough to develop a good noise contour map. What you could do, and probably what Massport has done over the years, is you could do a point-by-point analysis. What's all the noise at each individual noise monitor, and how does that compare to the modeled amount? And I think I've seen some of that data in the past. The two are not perfectly aligned, but for the most part, they do align very well.
Flavio or Steve, you have anything to add to that?
We do report what Richard is saying in our environmental data report, modeled versus measured. So that's in all of our EDRs. I agree with Richard. You couldn't really do the same analysis a model does clearly. The other challenge is that monitors pick up everything, so it's very difficult to. And that goes back to Steve's point about where the model is located. You may have a perfect location, but if there's a lot of local noise around it, that's going to really impact what the actual aircraft noise is. So the ADT provides that value of exactly honing in on the aviation noise. So I think with those two aspects, that's how we kind of present the information to the community is in the annual report.
And where
One
can
thing I'd
folks
like to
find
add
that?
as well-
Oh, sorry, Richard, go ahead.
One thing I just thought of as well that is worth adding is we do noise studies at airports. We occasionally the airports do choose to do some temporary noise monitoring. We're doing noise study at Martha's Vineyard right now, and they're doing some noise monitoring. And I can tell you, following up on what Flavio said about the noise monitor picks up everything. When we do temporary noise monitoring, the monitor is staffed the whole time, 24 hours a day. Because if somebody is mowing the grass or a loud bird goes by or the dog starts barking, that noise gets included. And you need to eliminate that to get good results on what the aviation noise is. So that's really it's so cumbersome. It's only used at a minimal number of points to get decent data.
Interesting. Okay. And Flavio, you mentioned the yearly report that Massport produces. Where can folks find that?
They can go to massport.com, massport.com, and we publish the reports there. Plus, Steve's office publishes a bunch of monthly reports as well. So that's all there.
Thanks. Okay, Flavio, next question is also for you. Flavio mentioned air quality being monitored annually by annual modeling of emissions. He then also mentioned some college-sponsored air quality monitoring. Is the annual report based on just the modeling, or does it also take the physical air quality testing data into account in the report?
The report that we publish is based on the model, the ATT model that Richard explained to everyone earlier. We do highlight individual initiatives in the report. So if there's some monitoring going on or some specific program, we'll flag it in the report. The intent of a lot of the support that we do is to inform the science so that the FAA or policymakers, the EPA can make changes in policy over the long run and inform everybody so that we can successfully, as the industry's done over the years, mitigate changes and drive the noise and emissions down over the years, as we have done, as you've shown we can do.
Okay, next question. I'm going to ask Heidi to jump in on this one. And it may be Steve too, Steve Phillips from Cape Air. I find it very abusive having all the prop planes with their avgas constantly flying over residential areas. Why can't they be mandated to fly over water and Suffolk Downs?
Thanks for the question, Colleen. You know, we, just like the rest of the community, have to make sure that we're deconflicted from all of the other traffic in and around the Boston area. So, you know, we also have certain requirements that we have to meet in terms of training and our flight operations to remain current. And unfortunately, not all of those can be done over water. Some do have to be done over land, and we do have to deconflict with the arrival and departure patterns out of Boston and the surrounding area. So it does limit, you know, some of the locations that we can operate, and we're restricted just by virtue of some of our requirements that we have to meet to do everything over water.
And Steve, I'm gonna call on Cape Air because I think Cape Air flies some prop planes, right?
We do. Our whole fleet is propeller-driven aircraft, and we do a lot of flying out of Logan. We fly down to the Cape and Islands, and we also go up to the New England states up north and west. And so that requires us to follow standard procedures, though, just like the larger operators, as we start talking about air traffic control procedures and the complexity of the airspace that we operate in. For safety, it's critical that we follow the same procedures as them. We do have the ability to do some more visual flying at lower altitudes that provides a little bit more flexibility for us to work with ATC on certain arrival routes. But for the most part, we're following standard arrival and departure procedures to blend in with the traffic flow. At some of the smaller airports outside of Logan, around the surrounding community, there are some voluntary noise abatement procedures at different airports. I'm thinking of like down in Martha's Vineyard, Hyannis, Nantucket, that we participate with their airport advisory groups as well to voluntarily comply with their local profiles as well. But standard and safety is key for safe operations.
Thanks. Question for Barrett. Why do arrivals to 33 left look like staircases rather than a smooth slope or curve? No other arrival path looks like a staircase. They are a gradual, smooth curve.
So I think what we're talking about here is our new RNAV procedure to runway 33 left. So aircraft that are arriving to Boston Logan in the overnight hours, we have weather permitting, we assign them that RNAV approach, and that keeps the aircraft over water for as long as possible to help alleviate some of our noise issues. Now, the flight path itself does curve towards the airport. If you look at the approach, it's not like a standard kind of square approach like you would normally have. It does curve towards the airport at a closer proximity. But it does look different. It's a different style of approach, keeps them a little bit higher, keeps them over the water longer, and puts them in a better position to alleviate some of the noise concerns that we've talked about throughout the day today. But again, it does happen usually only during our nocturnal hours. That's what it's designed for. It's not designed for higher capacity, and it doesn't get used during a normal day.
Okay. All right, we're getting towards the end here. This is going to be our last question, and I'm going to ask all the panelists to chime in. How does the partnership between FAA, Massport, and the operators work? So let me just kick it off. The FAA's mission is to provide the safest, most efficient aerospace system in the world. And management of the NAS, the National Airspace System, requires consistent coordination between all of those stakeholders. That includes the FAA, that includes the airport, the aircraft operators, and communities. And as part of that coordination, the FAA and Massport, we work together on a regular basis, not just on communicating regarding airfield and aircraft operations, but we work together in really all of the different functions, whether it be working with communities or working on environmental analysis or construction or maintenance of the different aspects of the airfield, day-to-day operations, safety and security. So the partnership there, we have a strong partnership. And, you know, I think I'll just say I'm from the Boston area. I've lived here my whole life. I think this team works extremely well together and are very sensitive and concerned about each other's challenges and requirements. So I think we have a real positive relationship, and maybe I'll pass it over to Flavio and get his perspective, and then maybe some of the airline folks could chime in.
I agree, Colleen. I think we meet every day. We have the 8:30 safety and security meeting where the FAA participates. Our operations folks at Bedford, Worcester, and Boston talk to the FAA every day, whether it's the local tower or the TRACON. Our other folks, we collaborate in advance on major, if there's major construction or things like that. We work at the policy level with the region, both the airports division and Colleen's office. So we are constantly engaged with the FAA, and we consistently relay feedback from communities when we hear from them. Steve's office works daily with communities, and he reaches out, and his folks reach out to the FAA and to so they can have a response to specific questions. So I think we have a very good rapport, and I would put it up against any other airport in the country, really, when I see my colleagues. And we really have a great rapport with the FAA, and I want to say with the airlines and stakeholders, both at all three airports. Thank you.
Thanks, Flavio. Steve, Heidi, Lee, any thoughts?
I guess I'll start. I've been working with both Massport and the FAA, specifically ATC, for about 26 years now, since I've been with Cape Air. And I would say the caring amongst that whole group is tremendous. Everybody has safety as their number one priority, efficiency and standardization, like we've talked about. But the communities is a big part of it, not only at Logan, but the surrounding communities that we serve, at least, is a big part of the caring community that we operate in. And so by meeting regularly to hear how we can improve efficiency and safety and coordination, like we've been talking about, is a real key there. But the people that have been involved really do have the communities in their heart when we both design arrival and departure procedures, as well as trying to make improvements. So I just want to put that part out there as well.
Thanks, Colleen. I would just add that, I think a safe system is one where we not only all individually put safety as our first priority, but it's one where we have to collaborate, right? With the complexities of our NAS, it is critical that we're all talking and communicating. And I think we've done a fantastic job of that through your leadership and Massport's leadership there. And your relationships with both community and the industry has been fantastic. And it's why we'll continue to have safe operations in and around Boston.
Thanks.
Steve and Heidi, I think, hit all the high points. I would just say from a JetBlue perspective, Boston is one of our focus cities. We have a whole bevy of our crew members that live and thrive in the area. So it's vitally important to us to make sure that we're considering what it means to live and work in the community, as well as operate our and provide service to the Boston area.
Thanks, everyone. I'm going to turn it over to Barrett to ask him to give us the last word on this.
Thank you. So from the FAA and air traffic perspective, safety it's not just a word we throw around. It's an expectation. What we do every day, we train, we communicate, we work to make sure that we continue to provide the safest, most complex national airspace system in the world. There's nothing else that compares across the globe. As far as communicating and dealing with Massport on a regular basis, we have telecons in the morning and in the afternoon to talk about what's happening at the airfield. We bring in the National Weather Service, talk about what the weather impacts are going to be for the day. So we make a really solid plan. After that, every 2 hours, we talk to the command center with all of our airline partners and talk about what's going on at our airports, what changes have occurred since we first talked first thing in the morning. It's a constant communication that ensures that every person who has a piece to this, who owns a piece of the safety program and ensuring that we do well, they all understand what's going on all the time. So we walk in the morning, it's safety. When we walk out, the expectation's the same. If we don't expect any less of our employees any day of the week. It's always about, this is the safest place in the world. Let's keep it that way.
Thank you, everyone. That's a great last question. And I want to thank the panel for hanging in with us. We went a little longer than we expected, and we got a lot of questions from our folks that have joined us today. So just want to mention a few items before we close out. As a standard disclosure, I want to say that this workshop and discussion do not constitute a final agency action or order, issued by the Secretary of Transportation under Title 49, United States Code, Section 46110. This meeting was informational only and as part of an ongoing dialogue between the FAA and its external stakeholders. We heard a lot of good questions today, and I hope our answers were informative. If you'd like to view this workshop again, please visit the FAA platforms on Facebook, YouTube, and Twitter. You may also visit the project website page shown on the screen. So thank you to our specialists for providing their expertise. We'll have one more workshop tomorrow, Thursday at 6 p.m. Have a good evening and thank you.